Let's try a classic systems of equations question involving wind resistance as well. This could be a water resistance current type question. A jet takes 4 hours to travel 200 kilometers against the headwind. On the return trip, the jet takes 2.5 hours to travel the same distance, now a tailwind. Determine the speed of the wind. So for this type of question, you have to memorize that distance equals velocity times time. And the way that we set up this resistance question is we're going to break this v into v plus the wind, v minus the wind, or if this was a water question, it would be the velocity minus the current or plus the current. So let's write down the first equation. A jet takes 4 hours, so t here is 4, to travel 200 kilometers, so the distance here is 200, against the headwind. So the key idea is understanding that a headwind is in your face, it slows you down. So it's going to be v minus wind, whereas a tailwind would push you along faster. So this is our first equation. On the return trip, the jet takes 2.5 hours to travel the same distance. So the time is now 2.5, and then here that's the velocity and the same distance. So on the return trip, we have the same wind is now a tailwind. So we're going to be going faster by that same wind amount. Determine the speed of the wind. We need to solve W. That's what we're trying to do. We have our two equations, and this is the hard part, is to set it up this way. The rest is just being careful about your algebra. So let's work it out here. I'm going to use distribution here. So 200 is equals to 4v minus 4w. And equation number 2, we get 200 is equals to 2.5v plus 2.5w. Now, it's up to you how you want to do this. You can solve for v and w if you solve v in terms of w with one of these equations and plug it in using substitution, or you can try using elimination. Now, I'm just going to use elimination here. So what we have is this equation. If I multiply everything by 10, it becomes 2000 equals 25v plus 25w. I want to get rid of the v's, so I'm looking at this top equation here, which has a v value of 4, and then I'm looking at this equation here, which has a v value of 25. What is the LCM of 4 and 25? I could think of the number 100. So I'm going to multiply this equation by 4 to make my v values 100, because once they're the same, it's very easy to eliminate these. So times 4, use your calculator if you need to, 8,000 equals 100v plus 100w. This is one of the key equations here. Now I want to get this to 100v as well. So to make this first equation have the same v value as the bottom one here, I need to multiply everything by 25, because 25 times 4 is 100. So we're going to focus on bringing this down here by multiplying by 25. 25 times 200 is 5,000 equals 100v minus 25 times 4 is 100w this way. So what I'm going to do now is I'm going to draw a line here and I'm going to subtract. It doesn't really matter whether you subtract down, up, or up, down, but we have to be consistent. 8,000 minus 5,000 is 3,000. 100v minus 100v disappears, and 100w minus negative 100w becomes 200w. This is a common mistake to accidentally mess up your signs. 100 minus negative 100w, the two negatives become a positive, so you're essentially adding. So w is equals to 3,000 divided by 200, which is approximately equals to, actually it's exactly equals to 15. So the wind here is 15 kilometers per hour. That's the units that we're using, kilometers per hour. So as soon as you read the word problem involving wind resistance or water resistance, remember your classic dVt formula, and we're going to break down the velocity into either plus wind or minus wind. expand it out and very carefully use either substitution or elimination, as we just did in this example, to derive your actual variable, unknown variable, which is w, which is what we're trying to solve. Systems of equations is one of the chapters that's hardest to understand and it's easy to make a mistake on. So if you understand this one here, great job.